Hey guys, welcome to our third video on factorising and solving cubics. So in this video we are looking at factorising and solving even harder cubics. In the previous video we were being told there were three linear factors, so we just used the factor theorem to find all three. That's all well and good, but you don't always know how many factors a cubic has. Remember, they can have 1, 2 or 3. So, first of all, again let me just remind you, we can write cubics sometimes as the product of 3 linear factors. Sometimes we can write it, or we can always write it actually, as the product of a linear factor and a quadratic factor. Now, sometimes this quadratic factor might have 0 roots, it might have 1 root, or it might have 2 roots. But they might not always be easy to find using the factor theorem. So what we're doing in this video, we are using the factor theorem to find one linear factor, and then that's going to enable us to find the quadratic factor. Then we can use the discriminant on the quadratic to test how many roots it has, and then find those two. So, quite tricky. Let's get going. Okay, so our first cubic here then that we want to factorise is x cubed and x squared minus x minus 1. So, first of all, then let's use the factor theorem to try and find a linear factor. So, as ever, let's just try f of 1. So, f of 1 is going to give us 1 cubed, which is 1, and 1 squared, which is 1, minus 1, minus 1. Now that is indeed equal to 0. So this implies then that x minus 1 is a factor. So we've got our linear factor. Good news. So what we could say now then is that f of x is equal to x minus 1 times some quadratic factor. So it's just some general quadratic factor. So we are going to call that for now x minus 1 times ax squared plus bx plus c. So ax squared plus bx plus c is some general quadratic factor. What we now need to do is find the values of a, b and c. So a and c are quite simple, b a little bit trickier. So what we do, we equate coefficients. What does that mean? Well, let's first of all think about the x cubed term that we would get if we were to expand these green brackets out. Now we're not going to do the whole expansion because that would be far more work than we need to do. But the only x cubed term that we are going to get from this expansion is x times ax squared. And that is going to give us ax cubed. Now that has to be exactly the same as the x cubed term in the original expression, which was just a single x cubed. So ax cubed has to be 1x cubed. Therefore, a is equal to 1. So we can fill in now a little bit of our quadratic factor. So we've got x minus 1 times, well, we now know a single x squared plus bx plus c. Now, when we expand this bracket out again, let's think about what constant term we are going to get at the end. So the constant term means the term without any x's attached to it. So here, that's going to be minus 1 times c. Now, up in the original function, we had a minus 1 as our constant term. So, we know minus 1 times c has to be minus 1. Therefore, c equals positive 1. So again, we can fill in a bit more. We've now got x minus 1 times x squared plus bx plus 1. So now we just need to find the value of b. How can we do this? Well, we can either find what x squared term we would get when we multiply out these brackets, or we could find what x term we would get. So I'm going to go for x squareds, I think. So in terms of x squared terms, we're going to get x times bx that's certainly going to give us an x squared term, and we're also going to get x squared times minus 1. Now if we sharpen this up a bit, x times bx is bx squared, and then minus 1 times x squared is minus x squared. Now we can factorise this into a single x squared term because we have a common factor of x squared. So we can say this is b minus 1 lots of x squared, like that. Now if we look back at our original cubic to see what x squared term we had a single positive x squared term. So we know b minus 1 x squared has to be x squared, like that. So if we divide through by x squared, we get b minus 1 has to be 1. Therefore, b is equal to 2. So now we can finally write our cubic as a product of a linear factor and a quadratic. So f of x is x minus 1 times x squared plus 2x plus 1. So again, let's just make sure you're happy here. This first bracket is a linear factor. This second bracket is a quadratic factor. Now, this quadratic factor can potentially have either 0, 1 or 2 real roots. So, what I'm going to do, because it's good practice, I'm going to use the discriminant to check how many roots we are looking for. You can factorise this quite easily, so you don't necessarily need to do this. It's just good practice, as I said. So the discriminant here of the quadratic is 2 squared, so 4 minus 4 times 1 times 1, so minus 4, which is 0. So that implies 1 real root in the quadratic. So now we can factorise that quadratic and say we could have done it before, we didn't have to use the discriminant. So we can finally write this as x minus 1 times x plus 1 times x plus 1, which we can sharpen up and write as x minus 1 times x plus 1 squared. Now if we want the solutions, so if we set this equal to 0, we've only got 2. First bracket tells us x is equal to 1. Second bracket tells us x is equal to minus 1. Okay, there's our first example. Okay, example 2. So 2x cubed add 11x squared add 6x add 5. So again, we want to write this as the product of a linear factor and a quadratic, and then solve and find out how many solutions we have. So, first of all, factor theorem. Let's try and find a factor. So, if we try f of 1, we're going to get 2 add 11, add 6, add 5. Clearly, that is not equal to 0, so that's no good to us. The next thing we want to try, f of minus 1. So, that's going to be a little bit trickier. Minus 1 cubed is minus 1, so times 2 is minus 2. Minus 1 squared is 1, so then we got plus 11. And then we got 6 times minus 1, which is minus 6. And then we got plus 5 on the end. So what's that? That's minus 2 add 11 is 9. Minus 6 is 3 add 5. Well, it's not equal to 0. So, neither 1 nor minus 1 gave us a factor. So, I'm going to erase this so we don't run out of room. So, what should we try next then for the old factor theorem? Well, should we try 2? Should we try 3? No. Look at the number at the end of the cubic. It's a 5. So, the next sensible thing to try would be a 5. So, f of 5, that's going to give us 2 times 125, so 250. Add 11 times 25, lovely, 275. Add 6 times 5, 30, and then add 5 on the end. Clearly not equal to 0. Bugger. Let's try f of minus 5. Okay, so minus 5 cubed is minus 125. Times that by 2, we got minus 250. Minus 5 squared is positive 25. 11 times 25 is 275. Then we've got 6 times minus 6 times minus 5, which is minus 30. And then we got plus 5. So, minus 250 add 275 is positive 25. Minus 30 is minus 5. Plus 5, it does indeed equal 0. So, this tells us then x plus 5 is a factor. So we've got our linear factor, now we need to find our quadratic factor. Okay, so I've written it out as our linear factor times the general quadratic factor. So now we need to find the values of a, B and C. So, first of all, we can find A quite easily. The only x cubed term that we would get when we multiply this out would be ax cubed. Now, up in the cubic, we've got 2x cubed, so we know ax cubed has to be 2x cubed. Therefore, a is equal to 2. Good times. Okay. So, we can now write this as x plus 5 times 2x squared plus bx plus c. Now again, c comes quite easily because that's just a constant at the end. So our cubic has a constant of 5. So that tells us then that 5 times c has to equal 5. Therefore, c is equal to 1. So, we can now write it as x plus 5 times 2x squared plus bx plus 1. Now you don't have to keep writing this out like I am here. I'm just doing it so you've got it nice step by step, hopefully nice and clear to follow. Okay, so then for our last step, we now need to find the value of b. So, again, you can either think about the x terms or the x squared terms that we're going to get here when we multiply out these brackets. So, we would get x times bx, which is going to give us bx squared, and we're also going to get 5 times 2x squared. So we can get bx squared add 10x squared, and we can factorise that to b plus 10 x squared. Now if we compare that to our x squared term in the cubic, we've got 11x squared. So b plus 10x squared has to be 11x squared. So b plus 10 is 11, therefore b is equal to 1. So finally we can now write our cubic as x plus 5 times 2x squared plus x plus 1 at the end, like that. So remember what we are trying to do here is work out how many solutions our cubic has. So we know it has at least 1 because we've got one linear factor. Now though, we need to play around with the quadratic, see if this guy has any real roots. So, the discriminant of this guy is going to be 1 squared, so 1 minus 4 times 2 times 1. Now 4 times 2 times 1 is 8, so we got 1 minus 8, which is minus 7. Now when the discriminant is less than 0, there are no real roots. So this implies the quadratic has no roots. So the only single solution to our cubic So the only solution for f of x equals 0 is, well, it comes from the x plus 5 bracket, so x is equal to minus 5. There we go guys, job is again for example 2. Okay, last example for this video then. I think I'm going to do one more on questions like this, because look how long they take. They are probably quite tricky. Okay, so here then we want to write x cubed minus 28x add 48 as a product of a linear factor and a quadratic, and then go on and solve. So, first of all, factor theorem. Let's find the linear factor. So, f of 1 is 1 minus 28 add 48. Nowhere near 0. That's no good to us. F of minus 1 is minus 1 add 28 add 48. Again, nowhere near 0. So useless to us. Let's try f of 2. So f of 2 is going to give us 2 cubed, which is 8. Minus 28 times 2 is minus 56. And then plus 48. Now, 8 plus 48 is 56. Minus 56 is 0. So, winner chicken dinner, we have our factor. So, this tells us x minus 2, x minus 2 is a factor. We have our linear factor. Now we want to write it as a linear times a quadratic. Find the quadratic, see how many solutions we have. Okay, first up then we need to find the values of a, b and c. So, hopefully you can see quite easily that a would be 1. So, a is equal to 1, x times ax squared will give us ax cubed, and we have a single x cubed in the cubic. C, we can work out c quite easily. Minus 2 times c is positive 48. So minus 2c is 48. Therefore, if we divide by minus 2, c is minus 24. So let's rewrite including those values. So we've now got x minus 2 times x squared plus bx minus 24, like that. Okay, so now we just need to find the value of b. Again, I'm going to go for the x squared coefficients. So, if we multiply this out, we are going to get x times bx, which is bx squared, and we're also going to get minus 2x squared, like that. Okay, now then if we look at the x squared coefficient, there actually wasn't an x squared term. So, we need bx squared minus 2x squared to equal 0, because there were 0 x squared terms in the cubic. So, if we divide through by x squared, we get b minus 2 is 0, and then add 2, b equals 2. So now we can write the cubic in terms of a linear and quadratic factor as x minus 2 times x squared minus 2x, sorry, positive 2x, and then minus 24 at the end, like that. Okay, let's check the discriminant then, it's the cool thing to do. So the discriminant of the quadratic is going to be 2 squared, so 4 minus 4 times 1 times minus 24. So it's going to give us a positive. 4 times 24 is 96. So we get a discriminant of 100, which is bigger than 0. So that implies 2 real roots. So we can actually factorise this quadratic quite nicely. It's going to be x plus 6 times x minus 4, like that. So our cubic in fully factorised form is x minus 2, so f of x is x minus 2 times x minus 4 times x plus 6. Now our solutions to f of x equals 0 are x equals 2, positive 4, and negative 6. Good times. Okay guys, that's it for this video. Like I said, I think I'm going to do one more video on more questions like this, because they are big and tricky.